Now that we've talked about valence electrons, we are going to talk about how those valence electrons are involved in atoms being held together by chemical bonds. And we're going to start by talking about covalent bonds. So a covalent bond is a bond that's formed between two atoms when those two atoms share electrons with each other. When you have two atoms that share electrons, they get held together, and that is how you form a molecule. So we talked about sugar at some point. Sugar is C6H12O6 is the chemical formula. That means it has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Specifically, that's glucose sugar. And so all of those atoms are held together into that sugar molecule because they're all sharing electrons with each other in covalent bonds. So let's give an example of hydrogen. We said that hydrogen has 1 electron and that first valence shell can only hold 2 electrons, and that atoms would really like to, they're the most stable, shall we say, when they have full valence shells. So hydrogen would really like to have 2 electrons in its outer shell. So each of these hydrogen atoms has 1 electron, it wants another electron, and so in a covalent bond, what happens is they share their electrons, and then they both have 2. And that satisfies both of their needs, and it creates a molecule that is H2, a hydrogen molecule made up of 2 hydrogen atoms. And then just to show you maybe slightly more accurate depiction, remember that the electrons aren't really orbiting in circles. Those circles that we use represent the electron shells or the energy levels, but really they're just kind of bouncing around in a cloud. And so when 2 hydrogen atoms share those electrons kind of bounce around in that cloud of both of those hydrogen molecules. Or both of those hydrogen atoms in that hydrogen molecule. So this is just a quick note on notation. Sometimes you'll see chemical bonds drawn by a line connecting the chemical symbols. So you can draw H2, 2 hydrogen atoms connected in a molecule. You can draw it with H and then a line and then H. That shows that they're covalently bonded together. Or you can write it with the number of atoms written as a little subscript down and to the right. So H is the symbol for hydrogen. There are 2 of them, and so H2 represents a hydrogen molecule with 2 hydrogen atoms. So what we just saw was a single covalent bond. You can also get a double covalent bond, which means that instead of sharing 1 pair of electrons, you share 2 pairs of electrons. So oxygen forms double covalent bonds with itself. So each oxygen atom has 6 electrons in its valence shell, and that valence shell can hold 8. So in order for that oxygen to be the most stable, it would like to have 2 more. Each one of them would like to have 2 more, and so oxygen atoms will often share 2 pairs of electrons. You can see 2 came from the one on the left, 2 came from the one on the right. And now, if you count them, they both have 8 electrons in their outer shell, counting the ones that they're sharing. And so that makes for a more stable molecule. So this molecule that you're looking at is O2. That is the oxygen that we breathe. And just like we said, you can represent a single bond with a line. You can represent a double bond with a pair of lines. So that little funny figure on the bottom with the 2 O's and the 2 lines in between, that represents O2 in a more diagrammatic, like visual way. And of course, molecules don't just contain pairs of the same element. They can contain combinations of all the different elements. So here you see water. Water is a covalent bond between 2 hydrogen atoms and an oxygen atom. Down below that is methane, which is I think it's what makes cow farts stink. So there's 4 hydrogen atoms covalently bonded to 1 carbon atom. And there's a couple of different things just to visually familiarize yourself with here. On the right-hand side, you see the space-filling model of an atom. That's just one way of a molecule. That's just one way that we'll draw molecules sometimes to give you a sense of the shapes that they have and what they look like. So these are 3 equivalent ways of drawing molecules that just give us different information. And The number of covalent bonds that one atom can form depends on the number of electrons that it needs to complete that outer shell, and that's called its valence. And that gets a little confusing because we have our valence shell and our valence electrons, but when we talk about an atom's valence, we're not talking about how many valence electrons it has, but how many valence electrons it needs. How many valence electrons it needs. So oxygen, that we said had 6 electrons in its outer shell, has a valence of 2 because it needs 2 more electrons to fill its outer shell. So oxygen, one atom of oxygen, can form up to 2 covalent bonds. So let's talk about a compound. A molecule has multiple atoms bound together. A compound, more specifically, has 2 or more elements bound together. So a compound is a type of molecule, but O2 is not a compound because it doesn't have 2 or more elements, it just has 2 oxygens in it. So H2O is a compound because it has hydrogen and oxygen. Glucose has carbon, hydrogen, and oxygen, so it's a compound. But H2, hydrogen gas, is not a compound because even though it's a molecule, it has more than one atom, it doesn't have more than one element. So molecule, more than one atom; compound, more than one element. Compounds are all molecules, but not all molecules are compounds. This is an example of a compound. So sodium, the silvery metal thing on the left, combined with chlorine makes the compound sodium chloride or table salt, NaCl. We went over that. Okay, so now that we know what compounds are, we're going to talk about electronegativity. So different atoms are able to kind of hold on to electrons more tightly and have more of some atoms have a stronger ability to pull electrons toward themselves. Oxygen is one of the most electronegative atoms. Oxygen really likes to grab onto electrons and hold them tight. And so sometimes in covalent bonds, one of the atoms will not share the electrons very nicely. It will hold them more tightly than the other atom. And that happens in water. So we're going to talk a lot about that in a little bit. But basically, that means that we can divide those covalent bonds where electrons are shared into 2 categories. In a nonpolar covalent bond, then the atoms share the electrons equally. So both of the hydrogen gas and the oxygen gas that we saw before, they share the electrons equally with each other. They are nonpolar covalent bonds. In a polar covalent bond, one atom is greedy with the electrons. They don't share the electrons equally. And because one of the atoms is kind of holding the electrons more tightly to itself, and electrons have a negative charge, one of the atoms will have a slightly negative charge, and the electrons, the other atoms that are in a bond with that molecule will have a slightly positive charge because their electrons are being pulled kind of away from them, and so they have a less negative charge there. So water is polar, and this has a huge influence on life as we know it, and we'll talk about that in more detail, but for now, let's just say that oxygen is really electronegative. It's sharing hydrogen and oxygen in the water. Each hydrogen atom is sharing a pair of electrons with the oxygen atom, and the oxygen atom is holding those electrons closer to its nucleus, and so hydrogen ends up slightly positive, and oxygen ends up slightly negative, and that ends up being really important in the way that water behaves, and yeah, we'll get to that. So, we've talked about covalent bonds, which included polar covalent bonds and non-polar covalent bonds, and also included single bonds and double bonds. Now we're going to get into a different type of bond altogether, which is the ionic bond. Ionic bonds happen when instead of 2 atoms sharing electrons with each other, one atom completely steals the electron from the other atom. And then, because the atom that stole the electron now has an extra negative charge, a whole negative charge, not a partial negative charge like the unequal sharing, but it steals the whole thing, so it gets a whole negative charge. And the one who lost an electron has an extra like is missing a negative charge, and so we say that it has a positive charge because now that it lost an electron, it has an extra proton compared to the number of electrons it has, so it has a more positive charge than it did. So let me show you an example here. Okay, so sodium only has one electron in its valence shell, and so that electron, sodium would be more stable if it had that second shell full and nothing in its outer shell. It'd rather have a full shell than that one little tiny electron hanging out on the outside. Chlorine wants one electron in its valence shell, and so chlorine will steal the electron from sodium, and then sodium has a positive charge, and chlorine has a negative charge because sodium lost a negative electron, so it became positive. Chlorine gained a negative electron, so it became negative. And so now we have two ions. So an ion is an atom that has either lost or gained one or more electrons. And when you have ions that have opposite charges, like sodium with a positive charge and chlorine with a negative charge, they are attracted to each other. So sodium and chlorine, that are now both ions, form an ionic bond. Sodium sticks to chlorine because sodium's positive and chlorine's negative. It's not as strong as a covalent bond because they're not sharing those electrons. They just kind of like to hang out with each other, but it is another form of bond. And when we're talking about ions, we call a positively charged ion, like sodium in that example, we call it a cation. You could think of it as like cats are happy, maybe. I don't know. If you like cats, then you associate it with positive. I do like cats, so I think it's positive. Anions are negatively charged ions. So cation, anion, and then the ionic bond is the attraction between the cation, the positive ion, and the anion, the negative ion. And then a compound that's formed by an ionic bond is called an ionic compound, like salt, like table salt, and then there's other kinds of salt. And salts usually form crystals, so like this. They form these nice orderly structures of ions that are stacked into these crystal forms, which is cool. One other kind of chemical bond that we'll talk about, not really kind, but category. So weak chemical bonds include ionic bonds. They also include two other kinds of bonds that we're going to talk about. That's what I meant to say. They include hydrogen bonds and they include van der Waals interactions. So covalent bonds are strong chemical bonds. Everything else that we're going to talk about is a weak chemical bond. And start with hydrogen bonds. Hydrogen bonds happen between water, for example. And hydrogen bonds happen when you have, it starts with those nonpolar covalent bonds. So actually, let me just show you a picture. So when you have water, the oxygen, that's very electronegative and greedy with the electrons, develops that slightly negative charge. The hydrogen has developed a slightly positive charge. Now, the positive charge on the hydrogen can be attracted to the partial positive charge on the hydrogen can be attracted to the partial negative charge on another molecule. So ammonia is another example of a compound besides water that forms hydrogen bonds. Ammonia, nitrogen, like oxygen, is very greedy with electrons. It's very electronegative. And so nitrogen in this molecule has a slight negative charge. So a hydrogen bond forms when the slightly positive hydrogen in the water is attracted to the slightly negative nitrogen in the ammonia. And now these molecules are slightly attracted to each other and they're going to be held together a little bit. Again, not as strong as a covalent bond, not even as strong as an ionic bond, but still a force that impacts life. Okay, last type of weak bond. Last type of bond that we're going to talk about are van der Waals interactions. And these are kind of a weird one. They're super weak, but they're important because when you get a lot of them together, the collective force is strong. So I'll actually show you these van der Waals forces are what allow geckos to walk up walls. Geckos have really, really fine kind of hairs, but they're not really hairs. They're I don't know, they have really fine structures on their feet that give them a lot of surface area, so that the atoms on their feet can interact with the atoms in the wall, and they on super, super close-up levels, atoms can be attracted to each other. And so the van der Waals interactions are just a very weak force that allows geckos to walk up walls, among other things. Okay, sorry, I know that this topic can be kind of confusing. We'll try to power through it. Let me know if you have any questions, and I can explain it again if any of that didn't make sense.